Hey, welcome, folks. Hope everybody's doing well, and let's just jump in, okay? Want to share some ideas with you. This is better problem solving through thinking and reasoning. My email address is on the screen. Twitter handle there as well. If you ever want to get in touch, you are more than welcome to do just that. Um, but first, I'm gonna say thank you. Thank you to you. I mean, I just saw all the stuff in chat box, like going on a Mediterranean sea cruise and playing golf and all that good stuff, and yet you spent some time with me and with us today to invest in yourself. I appreciate you for that. Thanks to Braving Camp, of course, as well for having me. So thanks for that too. By now, you're probably wondering what's going on with the cow, and if you're not, I'm disappointed. The problem is called cow eyes. There are 9 cows. The question is, how many eyes are there? You don't have to put it in the chat box. You don't have to draw a picture or do anything. Just think to yourself, like, how many eyes are there? I mean, you might imagine what your kiddos might do. They might do some multiplication, right? They might they might do some repeated addition. They might draw a picture. Somebody in this room right now is like, is he messing with us? The answer is yes. So this kiddo says that there are 14 eyes in the barn. Look at the work, right? 14 of them. 4 of the cows are facing sideways. And if you look at the picture, you can see that 4 cows are shown profile. Um, the cows kind of look like snakes, but we're not going to make fun of that. And it's hilarious, isn't it? And it's not it's beyond hilarious. I mean, it's unique. It's clever thinking. And this is a first grader from the past year in our school system, and it was marked. The problem was actually marked wrong. And I got a phone call from the parent wanting to know why it was marked wrong. And I talked to the teacher, and to be clear, she wasn't trying to get the kid in trouble. She wasn't. She was just in a hurry, and she's like, "The answer is 18, John." I was like, "Yeah, I know it's 18. Like when you think of 9 times 2, but this kiddo could justify their thinking, and they're thinking outside the box." And ultimately, she agreed that it should get credit. I was a little disappointed that it didn't up front, right? But that's okay. That's okay. I guess there's a bigger point to it, and that is this. When I thought about myself as a teacher when it came to problem solving, I would marvel when students had diverse insights and perspectives. They had different strategies and unique ways of looking at things. And sometimes their solutions were unique, like the one you see on the screen. As a first grade teacher, as a fourth grade teacher, as a middle school teacher, I was always like, oh my gosh, that's brilliant, right? But one of the things I reflected on after I had the conversation with this teacher was, did I actually nurture them, right? And it's not that I wanted my kids come up with a million different answers for everything that they did. But what I really wanted for my kiddos was to be able to think and reason for themselves. And I wasn't always good at doing that, right? Um, I sometimes struggle with it now, to be frank. So, what I wanted to share with you today is a couple of ideas on how do we help kids think better for problem solving. There'll be some bad jokes along the way. We're going to work with some Braining Camp apps too, which will be fantastic. And yeah, we'll take it from there. This session is based on my new work, Daily Routines to Jumpstart Problem Solving, as was shared with you at the beginning. I'll share, couple routines with you today. And it's not that these things are done daily necessarily, but that they're instructional routines for teaching problem solving. Okay. And I think they're practical. You might disagree. We'll find out in a minute. But first, let's jump in. Okay. Some of you are familiar with another one of my works, and that's about productive math struggle, something that I'm passionate about and something I'm really, um, a proponent of, and something that I think that I wasn't trained well to do. And that work is based on 6 actions for what do I do for promoting struggle. But if you look at one of them, supporting struggle is about how do I get stuck on my own? I don't understand what to do. What strategies do I have? How can I make sense of this? Like those are questions that humans like process and think about when they struggle. And that's our conversation for today. Like, what are some ways that we can teach problem solving so that kiddos can answer the questions on the screen when they struggle, not just with problem solving, but with anything, frankly. Speaking of struggles and challenges, I'm going to use the chat box. For those of you interested, take a moment to jot down something that makes problem solving hard for students. And just to be very clear, I know that often we say, like, well, they can't read the problem. I know that one's going to come up. Let's just table that one for now. Think up something else, fire it in the chat box if you want. I'll give you a few minutes to think. I'll shut up. What are some things that we struggle with? I know it says two or three, but maybe put in one. It'd be great. What are some strategies? Oh, understand the problem. Oh, look, now it just explodes. Okay, I can't even read all that. Now y'all just messing with me. Vocabulary, fair enough. Understand the problem. No, that's a good one, right? Thinking about it, knowing what to solve is a good one that comes up. Not being flexible in their thinking, Audrey. That's a nice one. There's a lot of great ones in here. Transferring their understanding, Jen. That's a good one. How do I get started? Right? That is a good one as well. Nice. They can't visualize it. We're going to talk about that one, Helen. We're going to talk about visualizing it today. Okay, now y'all just destroyed the chat box. I can't even. Oh, Becky, you talked about context, right? And that idea that I'm not being familiar with the context. Rushing, Ariel. Sometimes we talk about kiddos who struggle to get started, but others are like, done. And that's a problem as well. Yeah. Dang, there's so many good ones in here. Not sure about what strategy to use. Whatever you put in the chat box is the right answer. Congratulations. Now, I do recognize that sometimes kiddos can't read the problem, but I'm going to also argue that as humans, we don't always read the problem, right? So reading is part of this conversation, but it's more than just that, right? In fact, these might be some of the things that we lifted up in addition, right? Irma, great point. They're waiting for me to tell them what to do. And that's something that we need to address in this session as well, or I'll try to, right? But sometimes understanding the meaning of the problem, the context is not familiar to a student. Like there's problems about paying the bill at a restaurant that we ask the fifth graders, but they don't pay bills at a restaurant. So they don't even know if that is reasonable. Like, so that skill association on the lower left-hand side, that's where I've been multiplying for the past 3 weeks. So this problem's multiplying. I already know what to do. In other words, why read it if I already know what to do? I'm sure your kiddos don't struggle with multiple step or two-step problems, so I'm going to skip that one. Strategy Palooza down below, that's one of my own favorites. That's where I have so many strategies. I try to show them all to you. Better yet, I have no strategies, and I'm not sure, or I have so many I don't even know where to start. Making sense of the answer? And you can see some others, perseverance, anxiousness, how do I get started, right? And yes, again, the words can be challenging for all students, including our multilingual students, but it's not just the words. There's much more to it that can be problematic. I share all this with you because as a teacher, I try to address these challenges and more with things that I thought would solve my problems. There was a joke there if you missed it. Sorry. This is an education famous problem. You probably have seen it before. It's not my own. Yeah, Sheila, that's a good point there in the chat. And again, many of you are like, what in the heck is going on with this? Right? Well, if you have ever used this problem in second grade, it's subtraction all day long because kids are like, I don't know what you're talking about. It must be subtraction. And then you get to fourth grade, kids are like, must be division because I don't understand it. And they get to fifth grade and they just write a fraction because anything that's confusing is associated with fractions. I say that to you because this is a famous research problem. And the researcher found that 3 out of 4 kids will give you an answer to the problem. The question is why? Even when kids have the problem read to them? I think because some of the things I've done. I tell my kids to circle the numbers, they'd circle all of them. I tell them to highlight the words, they'd highlight the whole problem. I tell them to box the question because that always works. My kids can find a question mark, they didn't understand the question. I tell them to focus on labeling their answer. I mean, the things I did didn't work because it wasn't about thinking. It was just following me. They're like little sheep that follow me everywhere I went. So today, before we get started, the things that I did in my classroom, and maybe you have too, it doesn't make us bad people, it's just things that we tried, right? weren't really strategies. And they created students that, well, did what we told them to do, but didn't actually think like the kiddo who did the cows. If you don't think that metaphor is a good one, you can judge me, okay? All right, before we dig in, here's something I have done in the past. Maybe you've done as well, right? I had this really cool laminated chart with keywords on it, right, for all the different operations, and it was in different colors because that's what the brain research says to do. Spoiler, didn't work. If you read the first problem altogether, altogether means we should add. But in that problem, you actually have to subtract. Times means to multiply, but on the bottom, you actually have to divide. I'm willing to bet my mortgage that if I give second graders in many classrooms around the country a problem that has the larger number first and the word left in it 3 times, they will subtract right away. And I know I say sometimes, well, they can't read it, but I'd argue, why read it if I already know what to do? So on that note, what do I do instead? I did this in my classroom. Did you hear me say it? Okay. And I was frustrated when it didn't work because it wasn't thinking. So this is an instructional routine that I used in my classroom over the course of a week. We're going to use a BrainyCamp app with it here in a few minutes. I'm going to show you how it worked. It was a routine for helping kids recognize that sometimes there are different questions, and they call it same data, different question. And here's how it unfolds. If you've done it before, great. Be a cool time to check out the BrainyCamp tool with it. It really helps you when you struggle. Because when I struggle, one of the things I need to redirect myself to is like, what is the question? What do I need to answer? What information do I need? Right. And so, how do I help kids get themselves unstuck? Well, better problem solving. On that note, let's get started. So, I like to fire up a picture of one of my students. I've learned over the years to help them with context, the picture helps, right? Think about what do you notice? What do you wonder? Your kids might be like, bowling. Yeah. Red ball. See it. There's 10. Uh-huh. That's a strike. Oh, you bowled before. It could be a spare. Okay, fine. And so like noticing helps me activate their thinking, yeah? What do you wonder? Well, they could ask all kinds of questions and such. And though notice and wonder is great, it doesn't always make sure I'm in a good place with this. Yeah, Sheila, right? Like those are the things I want. I want to see what they notice about this so I can see what they know about a problem, what questions they might have. Oh, there's actually 9 pins there, right? And so, like, why are there only 9? Could be a wonder. So, notice and wonder, the work that came from Annie Feder and her colleagues is fantastic. I need you to hear me say that, but it's not actually problem solving. It's just activation, right? And sometimes I need to ask questions right behind it, like, where have you seen these? Have you played this game before? How many people can play? Like, I need to put those questions in there as well. And so, this might be how I start this instructional routine off for the week. Now you're like, okay, so what's special about this? Well, nothing. What I would do is I would put up a table of data like you see on the screen in a picture. Back in the day, I didn't have a picture. I did it on overhead. If you don't know what those things are, don't worry about it. My kids are trained to come in, they'd see this on the board or the screen, and they would get out their journals. And then what I would do is I would reveal a question. And I would say to my students, they were trained to do this. They would take a few minutes to solve the problem on their own. Then they would talk with a partner, commiserate, collaborate, question, and then we'd have a discussion as a class. And right now you're like, well, what's so great about this? Well, that's fine. I'd ask the class, like, what numbers did you use? And kiddos would say things like 993 and 719. And I'd ask why. And then someone might say, Mr. S, I used 719 and 905. Why did you use those? Why'd you use 993? And I mean, you get the idea, right? How did you select your numbers? Why did you add? How did you add? Like those would become part of the conversation. Well, that what happened on Monday. And while that doesn't seem very special, when my kiddos came in the classroom on Tuesday, this would be on the screen. Mr. Ross, we did this yesterday. Well, I know we did. Mr. Ross, are we just doing the same thing? Maybe. And I would reveal the question. What is the difference between the highest and lowest scoring team? And they would get to work on a new problem with the same data. And what I want you to do right now, based on what you see there, is to go to, Demari, that's awesome. There's the share code in the chat box that Jeff just put in for everybody. Try and select, I don't know, number lines as your Braining Camp tool and try to model the problem. Show how you would show the difference between the highest scoring team and the lowest scoring team. I'm gonna give you a few minutes to work on that. So if you click on that share code there, use that share code in the chat box. You can take a few moments to model that problem with the number line manipulative app. Give you a few minutes to do that. While you're doing that, you might be like, Mr. S, this isn't the same problem. I know. Mr. S, I don't think we can't subtract it this time. Well, we have to subtract this time. Okay. Oh, you can't see all the numbers, Melinda. Okay, I jacked it up. Can you give me 1 second, Melinda? My bad. I'm fixing it for you, Melinda. There we go. Yeah, so take a few moments to manipulate how you'd solve that problem. Thanks to the Braining Camp team, they took this entire routine and put it into a workspace for you. I'm going to give you just another minute or so. So as you wrap up your thinking, you're kind of exploring how like you can move those pieces. We're going to take a look at some work here in a second. Something that my kids might have done with Braining Camp had I had access to that years ago. All right, so we're going to move forward. You can keep mucking around with that and playing with it and thinking about how you would represent the problem, the difference between the highest and the lowest scoring team. But what I would do is my kids would work it on it independently, like you just did. Some of you are still doing, and that's okay. We would share and compare strategies, thinking. Hey guys, why did we have to subtract today? Because you were trying to find the difference, but how's that different than yesterday? Yesterday we were putting them together. Oh, that's why we added yesterday. Oh, Miss S, you used different numbers today. Well, I didn't, but the problem did. Did you know that some of my kids on day two would do the exact same operation as the day before? They would say, done. I'm like, whoa, 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 guys. Guys, you can't be done. Yeah, it's the same problem. You just changed the numbers. Did you read the question? Spoiler alert. No. I mean, you get the idea, right? And so that might be Tuesday. In fact, my kids back then, if I had access to Braining Camp, I might have had a kid put something up like that. Maybe somebody here designed something as well, right? They might have talked about adjusting those numbers to compute. If you take a look at this student's work, they might have them. We might have them display their work, right? And you can see how they recorded an equation with the pen tool to go with the app, right? And Angela's like, but Mr. S, I use usually you'd say addition, Mr. S, but right. Some kids will be like, well, Mr. S, I didn't do that. I did addition instead. And we could talk about, well, how did you do that? I might say, okay, then Angela, you're going to show your work next. P.S. You're not, right? I might put this up and share, have people to compare and contrast their work and their model and the jumps that they used, right? Another student might show their work like this. Oh, look, Angela, somebody else added too, right? Right? And how they counted on 81 and 193. In fact, these might be two different students working with that same tool. One of the things I like about this tool is that it's a forerunner for thinking about like bar models and bar diagrams on the number line. You see that down below, whereas the student up above showed the directions and the counting. You can turn those labels on and off. Now, I want to make sure you have time to do one of the next problems. So I'll go through this next part a little bit more quickly. Before I do, though, this is how it goes down, right? I pose a problem, my kids work on it independently, and then we talk about it. And each day I want to change out the problem. And again, I didn't have access to Braining Camp back then, but had I might have had my kids do it like you and do the problem on Braining Camp, share those things out, right? And talk about the equations that we write, the models that we make. Anyhow, that might have been Tuesday, right? My kids would come in on Wednesday, and back then, again with an overhead, they get out their journals and there'd be a new problem. Now you might think like, oh, man, I don't have time to do it every day. And so maybe this would be a center or an independent activity or maybe a homework. So maybe it's not done in class every day and discussed, but that would have to happen a few times. And one of the things I learned, and something you probably already know, is that kids rush to solve a problem and don't think much about what's happening, right? They just grab numbers and do something with it. And I wanted to focus their attention on sense making. In this case, a student on this third day might have used base 10 models, these decimal discs on 10 frames. I'm sorry, Alyssa, they want to be done first, right? And so I had to start changing up the question each day with the same data so that they would slow down and pause and think about all the different questions that could be asked and are they making sense of it. And as they would come in, like that's Wednesday, but then on Thursday they would come in and you're never going to believe it, but there's a different question on Thursday, right? And they're not always addition and subtraction. There's all kinds of questions that I could do. And if you teach primary grades, I'm going to show you yours in a second. But before I wrap this up, that might be Thursday, right? I learned to do something special on Friday. I was teaching fourth grade, and math was the first class of the day, and we were having a team breakfast, and the bell rang, and kids came in, and I wasn't ready for them, and they're like, "Mr. S, we need a question. Do you have one, Mr. S? What's the question?" I was like, "Oh, why don't you all write your own question?" So it's an experience of 4 days in a row where kids solve my problems that are different that force them to read and focus. And then on the third day or the fifth day, having them write the question. And sometimes my kids wrote really good problems, and sometimes they were horrible, right? And sometimes they're really hard. And if you work on a team with other teachers, you could collect those questions and pass them to your partner. So as I move on, primary people, this is for you as well. It's just your problems would look different, right? Single digit, double digit problems, who has the most, who has the fewest, may not always be an operation. And before we move on, I just want to lift up one more thing. Take a look at the red box. So the red box is another one that I would use from time to time. And in my classroom, like some kids would get to work and some groups wouldn't. I'm like, guys, why aren't you getting to work? Mr. S, who's Jake? What are you talking about? There's no Jake on the chart. Oh, there's no Jake. And then we'd ask the other kids, what are you doing? And they'd say things like, we just made up a number for Jake. I'm like, you can't just make up numbers. They always assumed that there was a problem to be solved, right? And if you teach later grades, it works with fractions, right? I mean, it works with everything. The whole point is changing up the work, changing up the problem each day, and having kids show their thinking, but to also have them show their thinking with resources like virtual manipulatives provided by Brain Camp. One of the things I love about this is like now I'm using these fraction tiles to model a problem, not just showing that I understand how to solve the problem, but also I understand the concept of what's happening with our fractions. And that in this case, the kids made a model here, but then they could draw all over it on top of that, which is really, really helpful with the draw tool. Because sometimes with the real thing, you can't capture all of those changes, right? And then the pieces fall on the floor, maybe. I mean, you get it. You know that feeling. So I'm going to wrap this up. This is one instructional routine that I found a lot of value in called Data Different Question, where I would provide data, but I would change out the question each day. So they would start to focus in on that question and that number selection and why. We have time for two more instructional routines. One you're going to work with again with Braining Camp, and then one I'm just going to walk you through. But before I do that, can I share something with you? When I realized keywords didn't work, I started doing this. I was like, all right, guys, circle all the numbers, underline the important information. Like I made word problems a procedure. And while my adult brain kind of likes that, it's not really how kid brains necessarily work. And though they do need a process per se, this could be a bit too restrictive, too much of a gimmick, and it's not real thinking. What's interesting is colleagues Beth Gobet and Lisa Andrews explored the different process charts around the country and in the school, and found there's processes for cubes and super views, Q-tips. That's kind of gross. I don't even know what that anchor chart looks like, but I bet it's kind of gross. But imagine you're a kid in a school where the process chart changes each year, and one year P means picture, and the next year means plan, right? Like, if you can read the problem, great, but if the process is all, well, you get the idea. And while we do want to provide kiddos with opportunities for structure, we really want to provide opportunities for thinking. I tried process charts like this, and they did not work well for me. Yes, my kids could box a question mark, but that doesn't mean that they understood the question. So, in our last 10 minutes, 15 minutes together, I want to do two other instructional routines. Mind you, I write about 20 of them. I'm just lifting up a couple that I've loved over the years. This next one is called They Did What? Sometimes helping kids interrogate their own work, it's really helpful for them to practice analyzing somebody else's work. This is one of my all-time favorites. It only took like 10 minutes. I do it a couple times a week, and then I put it away for a while. But what I tried to do was train my kids. I would train my kids to does that make sense? Like, you know how you'd always ask your kids, like, did you look at it? Tell me more about it. Like, I wanted them to do that for themselves. And it's a really powerful tool because, like, when you're struggling, you need to think to yourself, like, how could I show this problem? What's wrong with my work? That just doesn't happen by magic. We have to teach that. And I didn't always do a good job of that. So let's try it now, okay? First, take a moment to read the problem. All right. So one of the things I learned to do to promote agency and help was I stopped reading the problem to my kids all the time. I post it, let them read it to themselves, talk about it, ask me questions. Can we read it together? Okay. Right. That's an important part of this conversation. But then like having them like create a representation to compare. So what I want you to do for now is just to explore a tool. And then I'll tell you how this whole routine works, okay? What I want you to do is use any manipulative in the Braining Camp collection to show this problem. And then if you follow the directions on there, you'll click on share and copy the image, and then you can actually paste it directly into the Zoom chat box. In fact, well, I'll just let you do it. Take a few moments to model the problem, copy, and then ultimately paste your picture into the chat box. You can see the whole thing. It'll be pretty cool. I'm going to give you about, I don't know, 5 minutes or so, and then I'll tell you how this whole routine actually works. Okay.
And if you have any difficulty copying the image into the chat, there when you click on the blue share button within Braining Camp, you also have the option of downloading an image. And then within the Zoom chat, there's an option where you can upload an image if you have any issues. So like John said, you're welcome to use base 10 blocks, place value disks, 100 board, any manipulative that you think would be helpful to solve this problem.
You can see some examples popping up there in the chat box, screenshots of students' work. I'm gonna give you some more, I don't know, a couple more minutes just to try to model the problem, and I'll tell you how this works. The routine itself, that is. Okay, Becky. It's okay if you can't paste in the chat. It's okay, no problem for anybody. You can see some screenshots that did pop into the chat. If you can't, again, no worries. No worries. I'll give you just another 30 seconds to work on it. And then I want to make sure that you understand how this instructional routine works for thinking is my greater goal for us. Perfect, Deb. Sometimes just tell me how you did it works. So for those of you who can't get a picture in or having some other issues, it's okay. In the interest of time and the fact that it's summer and many of us want to go to the pool, let's move forward, okay? So again, here's how this routine works. Sometimes I'm using with Brady Camp routine resources, sometimes I'm not. Um, what I would do is, again, I'm posing a problem to my students, right? And I'm going to let them represent it, or better yet, I'm going to have a representation all ready to go. Do you hear me say that? And so kids get a chance to read the problem, and then I'm going to post somebody's work, like you see on the screen. And this is a case where kiddos did the work in their journal. And then I'm going to say, talk with a partner. What's a question you have for the person who solved the problem? What's something you like about their work? And kids might say, Mr. S, I love how they did a B and a T because that was the dinosaurs. Oh, I wonder what are the lines we show how which one's longer? That makes sense. Yeah, I think so. Mr. S, I noticed that they used a number line to kind of think about where the dinosaurs go. Oh, yeah, that makes sense. Mr. S, what does 32 longer mean? Oh, that's a good question for whoever did this. Mr. S, why did they do two equations? That's a good question for this person too. Oh, I know why. You get the idea, right? So how this works is you pose a problem, kids think about it, and then they interrogate, analyze, explore someone else's work, ask them question to give them feedback about it. I mean, you get the idea, right? I mean, you get the idea. And what's cool about it is it works great in a journal, but I could have a pre-made thing ready on Brain Camp, or in this case, we were going to have a couple in the chat box that we could respond to. But like, take a look at the kid on the screen, right? Let's say a kiddo does this, and or maybe I have this ready for them, and I post it up. I'm like, talk to me, folks, about tell me, kids, about what did they do on the problem? Like, how did they represent the problem? They use a number line. Okay, what questions do you have for them? I mean, you get the idea. There's no wrong way to go about this, but essentially what this routine is to help kids think about what is a good way to represent a problem? How do I make sense of a problem? Right? I mean, this is one where I've created a model with a Braining Camp tool, and then the kids would interrogate that, but it works just as well with student work, right? Let me give you another example. the first time I did this, it was a couple years ago. I was doing this exact problem with kids. And so they all read it. And then I put up the student work that you see on the screen. And I said, what's a question or something you notice about this person's work? And this little girl raised her hand right away. She was like, Mr. S, why do they do jellyfish? I'm like, jellyfish? What are you talking about? Oh, those are jellyfish. Does anybody know what those are? Yeah, those are the chairs. Oh, what else could she have done? She could have made fours in there. What do you mean? Well, she could have made boxes with fours and counted that way. I got it. What's the question you have for her? Where's her equation? And so, in this situation where I create a model of the problem and have them react to it, is really, really powerful one. Like, I'm not always going to have them create it and then share. In fact, I'll have one ready to go. But I also wanted to lift up things that I wanted to stress. My point to you is simply this. I had kids that when they would try to solve this problem, right, they would try to draw every chair with a different wood grain pattern and different stains. Right. And to Ryan's point in the chat box, like sometimes kids like might well their chairs around the table. Like, did you bought that one? And so their answers might change differently. And their representation I might lift up might look differently because there is some open-endedness to this problem, right? So how this whole thing works is I pose a problem, they think about it, and then I pose some work for them to interrogate. Oh yeah, Becky's like, but what if people were sitting in those chairs? And so that drawing might create some different situations, right? Again, a problem that could be done where I ask kids like, okay, this is their work. What do you think they should have done to their work to make it better? They should have wrote an equation. I couldn't agree with you more. Oh yeah, Tammy. Like the table legs piece, like agreeing with Jeff. This is what that same problem might look like with a braining camp representation. In fact, sometimes you could have a kiddo do some kiddos doing their journal and some kiddos do a braining camp representation and see how the two tools, how the representations compare, right? I mean, that's an option. But in this routine, essentially what I want to do is pose a problem and I want to have student work or some example representation already made for them to react to before maybe they create their own, right? I want them to practice analyzing somebody else's work, right? And sometimes it could be as simple as I pose a problem and the work has been started, but they have to think about like, what does that person need to continue? Because sometimes kids get stuck in the process and they have to pause and think about, okay, what else do I need to be doing? So we don't have much time left together. And I want to make sure that you get just one more idea, right? But these are like instructional routines, things that I do routinely to help kids make sense of problems. This last one's called match the equation. It's a routine for representing problems because we know that writing equations are an important part of problem solving, right? But that in itself can be a struggle. When I struggle, I have to think about like, what does my equation look like? How is the equation represented or collected or connected to the problem? Yeah, I think that's a good point, Tammy. Like I was going to put those pieces in there. Yeah, without a doubt. Well, along those lines, here's how this would work. First, I pose a problem to my kids, right? And I say to them, go ahead and take a moment to read the problem. And then on their whiteboards or their journal or whatever, I say, write down the equation you think you could use to solve this problem. And after they do that, then I pose forward and I say, talk with the partner and tell them how your equation matches one of my equations. And if you agree, it's a good. Thanks, Tammy. Does your equation match mine? Then we all talk about like which of mine match the problem. Sometimes evaluating an equation can actually cause some problems with the word problems. Now, if you don't like the idea of them making the equation first, another way to go about this is they read the problem and then you just put up two equations or four equations, right? And they match the equation with the problem. What I mean by that is I wouldn't even have them generate it, right? I might choose not to have them generate it. I might just have the problem, put up some equations, and talk about which one matches. And you'll hear things like this, Mr. S, A and B. Huh? It says A and B, they both equal 64. Oh, they do. But only one of them matches the equation. Nuh-uh. Well, it does. Because 36 and 28 are the numbers we have to be using here, right? Even though they both equal 64, that doesn't mean they both match the problem. And sometimes kids, when they are blind, just computing, don't see how we have to represent a problem. I mean, I could have them just not even work with equations and work with. This is one where I used our base 10 blocks at Braining Camp and said to my students, after you read the problem, which of these representations matches the problem, and how do you know? This might be the first thing, and then I would do the equations right after it. And while you can use the commutative property to solve, right? I agree with you, Marcia. When you look at this problem again, the numbers in the problem are 36 and 28. So you can do 36 plus 28 or 28 plus 36, but 38 and 26 are not actually in the problem. They don't actually represent the correct quantities. And so you might have situations where the equations are reversed via the commutative problem process, but it's really important for them to have the correct numbers in there, right? Right. And so I might create a representation and and talk about which one matches, like you see on the screen, and then do the equations. But one thing that's important here is they're not really going to. I really like it better when they don't create either. I've already created a couple, and they then make a connection to it. And to your point, Becky, it depends, right? Maybe I'm beyond representations, and now I'm just practicing the equation matches. Again, this always works. It could be a situation where more than one equation works for students, and they might make an argument about which two work and why, because there are different ways to represent it. Sometimes the solution alone is problematic, so it might be just like, let's match the equation with the unknown. Like, we don't know the solution, but how would you form this one? And I know that sometimes kiddos struggle with two-step problems. My kiddos did too. So this might be a more advanced version with later grades where students solve a problem or think about the problem. And then I say, look, guys, you need two equations to solve this problem. Which of these match? And if you're overwhelmed by four equations on the screen, maybe I would just put up two choices. Does that make sense? So the four choices on the screen, I might just put up two and have them make an argument for which one represents the problem and which one doesn't. On that note, this is a routine called match the equation. It's one of three I shared with you today. One where you give new data every time, keep the data staying, but you give new question each day. Another one where you pose a problem and give some student work created on Braining Camp or in their journal for them to analyze. Because by analyzing work, I can now be better skilled to analyze my own. And then one where I can match equations to a problem. Like, these are different experiences. And Marcia, by the way, for specially designed instruction, that is a really good point that I might label step one and step two. That's a great, great point. But they could still, students who need that specially designed instruction can still engage with the routine. What a nice ad. Thanks for that. So on that note, I don't need my kids to come up with a million different answers for calories. But what I do need for my kids is to be able to think. Thank you, Marcia. And thinking takes time. And one of the things I need to do is think about, how do I help them learn to think? What is my instructional practice for that? So, on that note, I want to say again, thanks for spending the summer day with me in just a few minutes. I only went through three of a couple of my routines, right? Before you leave, before you head out, thanks again for spending some time with me. Know that there's all kinds of things that could resonate. Go to the pool later today, or you're in the soccer field. Think about like, how do I help my kids think? Thanks again to Brainy Camp for having me. Thanks for spending some time. Have a good rest of your summer. Have a great school year. And if you ever have questions, my email is right there. Take care, folks.